that VA is equal to VB plus by omega AB cross R A from point B. Okay. So we know that this is our V naught. Okay. And over here we have a velocity going this way. This will be our VB. Okay. So VA is equal to minus VBI. Okay. Plus, so if it's going this way, I'm going to assume plus by, so I'm going to assume that this is going to go in a anti-clockwise direction, minus or positive omega AB K cross R, so from point B, so this is equal to 60 degrees. So it will be equal to 8 cos 60 I plus by 8 sine 60J. Okay. So when I open this up, so cos 60 is equal to omega AB K cross of 4I 8 sine 60 6.928. Yes. Yeah, from point B, right? You're right. So from point B, so both are minus. Thank you. So A, so this is B, so minus minus. You're right. So this is negative, and this is negative. So 8 cos 60, 4, 8 sine 60. Yes, thank you. So this is equal to minus VBI. K cross I is positive. K cross I is positive. So minus 4 omega AB J. K cross J is negative. Negative will be positive. 6.928 I. Okay, so that is my, oh yeah, omega ABI. Okay. Anything else you can get from here? So we know that this is our velocity at A. Now, if we look at velocity at A, I just realized this. Velocity at A, does it has a J direction? If we look at velocity at A, right, it is exactly vertical, yes or no? Right? I mean, it's exactly from point O directly down. So when that's the case, maybe, not maybe, I'm very sure this is at velocity A. Yes or no? Right? Because it's at horizontal. A is exactly on the what? On the vertical plane. So it only has what? An I component. So from here, you can write that this is also equal to minus I. Okay. So if we were to write for an I component, so for I component, we know that we have a minus VA is equal to minus VB plus by what? 6.928 omega AB. So for J component, we know that J component, do we have at a J component? So this is 0. So this is equal to minus 4 omega AB. So from here, we know that omega AB is equal to 0. Okay. Now, we did this. If I were to, have you seen the solution manual? Yes or no? The solution manual did not do this approach. Okay. The solution manual states that the instantaneous center from point A goes to what? Infinity. Yes or no? Right? Right. So if you don't want to use that, you don't need to. Okay. But I've shown that without using instantaneous center, we are okay. Am I right? Right. Without using instantaneous center, we are we okay? Yeah. We are okay. Okay. So now coming back to our point, so that's all the equation that we can form now. So now if we were to look back into equation number 1, okay, acceleration A and acceleration C, okay, we don't know what is happening. I mean, I don't know what is happening at point C. I'm very hesitant for now to assume that acceleration at point C is equal to 0. Okay, I'm very hesitant. Okay. Anyone? Yeah, I'm as I say, I'm very hesitant to assume that it is equal to 0. So if you are not sure, okay, don't do it. Okay, I repeat again, you are not sure, don't do it. Okay. So next we can form one more equation over here. Okay. So we can form point A relative to point O. Okay. So this has been proven. So acceleration at point A equal to acceleration at point naught. Okay, so that's another equation that we can form. Plus by alpha cross R A from naught minus by omega squared R A from naught. Okay. So acceleration A, do we know the value for acceleration A? So I'm going to write down first. So acceleration, did I just form? So acceleration at point A is equal to acceleration at point naught plus alpha is equal to 12k cross R point A. Okay, R from point naught is so minus 2j minus by omega squared. So this is 36, right? And then this will be equal to minus 2j. R A from point naught. Okay. So we know that acceleration at point A is equal to acceleration at point naught plus K cross J is what? Is negative. So this is 24I. K cross J is negative. There's a negative over here. So minus by 36 times 2 minus plus by 72J. Okay, so acceleration at point A is equal to A naught. Okay. Now there is a formula to determine A naught. Okay. So I can't remember the formula. Anyone? So we know that V is equal to R omega. Am I right? So acceleration is equal to what? Is there a formula sheet? Let me look at the formula sheet. So acceleration is it equal to is it alpha R? Let me check. So if we were to look at our formula sheet, is it given? Can you all see this? Yes or no? Right? You can see this, right? Right? So this is equal to what? Alpha R. So in fact, we can determine what is our A naught, right? So note that A naught is equal to alpha R. Okay. So alpha is equal to what? 12. And the radius is equal to 3. Right? So 12 times 3 is equal to what? 36 inches per second squared. And I'm going to make the assumption that it's going to follow our velocity. Okay. So therefore, acceleration at point A is equal to minus 36I K cross J plus R A from naught, yes. So K cross J is 24 minus 24 minus K cross J, okay. Plus by 24I plus by 72J. So over here we have what? This is equal to minus 12I plus by 72J. Okay. So we have our acceleration at point A. So they want us to determine the magnitude. So what this means at point A, okay, at point A, so if I were to copy this diagram again, we are given that the acceleration is minus 12I. Oh, acceleration at point A, Eugene. Okay. We know that it's going at minus 12I. And the vertical component is 72J. So now we are going to determine acceleration at point A. Okay. So the magnitude for acceleration at point A, in fact, this is a very good example. Okay. 12, so it's equal to minus 12 squared plus by 72 squared. So this is equal to minus 12 squared plus by 72 squared square root is equal to 70.99. This is 70, so 12 squared plus by 72 squared square root 73 inches per second squared, and the orientation theta is equal to inverse tangent 72 divided by 12. Okay, so 72 divided by 12 inverse tangent